Yo, what's good? Welcome back to the series. So we're talking about Solana Cookbook. We're just doing a deep dive on the documentation of the architecture of Solana, the components that play in the network, and how to use them. So we've talked about accounts and we've talked about programs. So in this video, we're gonna wrap things up by talking about transactions. So clients can invoke programs by submitting a transaction to a cluster. A single transaction can handle multiple instructions, each targeting its own program. So inside a transaction, you can have, boom, one instruction that's like, oh, I want to talk to Jimmy's wallet. The second one can say, oh, I want to talk to Magic Eden, the NFT marketplace. And then the third one can say, hey, I want to talk to Manuela's wallet. So three different accounts that we're interacting with, or a different program or a smart contract saying, oh, I want to talk to Magic Eden's contract of this NFT with this specific instruction. When a transaction is submitted, the Solana runtime will process its instructions in order and atomically. If any part of an instruction fails, the entire transaction will fail. Fact sheet: instructions are the most basic operational unit of Solana. So they are essentially how things get done. Each instruction contains the program ID of the intended program, so typically in the form of a public street or a public key, an array of all accounts it intends to read from or write to. So all the accounts, I want to talk to Manuela's account, I want to talk to Jimmy's account, I want to talk to Maktub account, all the accounts. And then third is the instruction data that is specific to the intended program. So I want to talk to Manuela's account and I want this instruction. I want to move 5 SOL from this Manuela's account to Jimmy's account. Multiple instructions can be bundled into a single transaction. So you can think about it like one transaction can have multiple different instructions, and we want to do certain amount of tasks in this one transaction. So in order for one thing to happen, it's like we have to do all of these things at once. Each transaction contains an array of all accounts it intends to read from or write to. So again, we want to make sure we have all the accounts that we want to talk to in a specific transaction. We want to make sure, like for example, if we're going through a portal like Wormhole. If you're familiar with Wormhole, it's a portal that allows you to jump your assets from like Terra or Ethereum to Solana, for example. So you're able to take this one 5 tokens of Ethereum and send it to Solana, but that's one transaction. Well, it's masked in a few different layers of stuff, but essentially you're trying to complete one transaction, which is I want to send 5 Ethereum and I want to send it to Solana. So that's one transaction, but then there are layers to how the different instructions work inside of that transaction. Essentially, that's an example. So one or more instructions, a resend block hash, one or more signatures. Instructions are processed in order and atomically. If any part of an instruction fails, the entire transaction fails. Transactions are limited to 1232 bytes. And that's more of a technical detail. Whenever you get into the development phase, that's something you will think more about. So Solana runtime requires both instructions and transactions to specify a list of all accounts they intend to read from or write to. By requiring these accounts in advance, the runtime is able to parallelize execution across all transactions. So if we're dealing with 3 different accounts, the Solana runtime can do all 3 different accounts at the same time because they don't conflict with one another. So when a transaction is submitted to the cluster, the runtime will process its instructions in order and atomically. For each instruction, the receiving program will interpret its data array and operate on its specified account. The program will either return successfully or with an error code. If an error is returned, the entire transaction will fail immediately, so the transaction will not go through. Any transaction that aims to debit an account or modify its data requires the signature of its account holder. So in order to actually remove money from an account, you have to get a signature from that account's wallet holder. Any account that will be modified is marked as writable. So whenever you want to modify something in some account, you have to mark it as writable in the code. An account can be credited without the holder's permission so long as the transaction fee payer covers the necessary rent and transaction fees. So if you want to send, some Solana or any other SPL token to a wallet, you don't need that person's permission. You can essentially just send it. It's going to go through. The other side of it, the flip side of it, is if you want to remove money from someone's account, you can't do that without getting a signature from that person or account or program, whichever is in that situation, essentially. Before submission, all transactions must reference a recent block hash. The block hash is used to prevent duplications and eliminate stale transactions. So it's trying to keep a reference of where in the blockchain the current time is to make sure some random duplicate or fork doesn't happen sometime in the future where it's like a duped, transaction that pops up twice and then you take someone's money twice or something. The max age of a block hash is 150 blocks, or about 1 minute and 19 seconds at the time of writing this. So, the Solana network collects two types of fees. We collect transaction fees, aka gas fees, so whenever you want to make a transaction happen, but also it takes rent fees for storing data on chain. So there's gas fees for making things go, and there's gas fees again for making things stay. So two sides of fees, but relatively similar. It's fees in the end of the day. Transaction fees are deterministic. There's no concept of a fee market in which users can pay higher fees to increase their chances of being included in the next block. So Ethereum has this problem where they have gas wars. Like if you're willing to pay $1 million to get your block first, then you will get your block first because you can pay the higher gas fee. But in Solana, there is no highest bidder market. It's essentially just whoever kind of comes up in the transaction is able to go. So transaction fees are determined only by the number of signatures required, LAN ports per signature, so how many little pieces of fraction of SOL per signature is needed, not by the amount of resource used. This is because there's currently a hard cap of 1232 bytes on all transactions. All transactions require at least one writable account to sign the transaction. Once submitted, the writer signer account that is serialized first will be the fee payer. This account will pay for the cost of the transaction, regardless of whether the transaction succeeds or fails. So whoever is signing off on the transaction as the writable is going to pay a fee, and if the fee does not have a sufficient balance to pay the transaction fee, or the fee payer doesn't have a sufficient balance to pay the transaction fee, the transaction will be dropped. At the time of writing, 50% of all transaction fees are collected by the validator that produced the blocks of validator nodes, while the rest of the 50% are burned, forever removed from the network. This structure works to incentivize validators to process as many transactions as possible during their slots in the leader schedule to make sure they earn as much as possible. This is transactions that we just broke down. So the next piece we are going to talk about is the final key concept of Solana architecture, which is program-derived addresses. Okay, so that was transactions. That was fun. We just talked about the third most important piece of Solana's architecture. So we are going to revisit the next part. Don't get too eager. The next one is coming very soon. So we're going to be talking about program-derived addresses. Anyway, if you enjoyed this video, make sure you destroy the like button because I'm going to continue to make awesome content like this. Let's dive deep into Solana's network. Let's understand the cookbook from a learning and just foundational understanding perspective before we get into the development and programming and testing stuff around. Let's understand the network, from an architectural perspective and see what pieces we're playing with whenever we do hop into the code, so we know what's going on in the background as we mess around with things. Anyway, it was your boy Elijah, and I'll catch you on the next one. Peace.
Don't speak to no one but the facts to the masses.